Let's go back to the early days. What did the formation of the Milky Way galaxy look like? Or maybe we want to start even before that. What did the formation of the universe look like?
Well, we scientists believe there was the Big Bang, some big beginning. But what is important for my work, and I think that's what we're going to talk about, is what kind of elements were present at that time.
Mm-hmm.
So the Big Bang left a universe behind that was made of just hydrogen and helium and tiny little sprinkles of lithium. And that was pretty much it. And as it turns out, it's actually quite hard to make stars or any structure from that. That's fairly hot gas. And so the very first stars that formed prior to any galaxies were very massive stars, big stars, 100 times the mass of the sun. And they were made from just hydrogen and helium. So big stars explode pretty fast after a few million years only. That's very short on cosmic timescales. And in their explosions, they provided the first heavier elements to the universe because in their cores, all stars fuse lighter elements like hydrogen and helium into heavier ones. And then that goes all the way up to iron. And then all that material gets ejected in these massive supernova explosions. And that marked a really, really important transition in the universe because after that first explosion, it was no longer chemically pristine. Mm-hmm. And that set the stage for everything else to happen, including us here talking today.
So what do you mean by pristine? So there's a whole complex soup of elements now as opposed to just hydrogen, helium, and a little bit of lithium.
Yeah, so after the Big Bang, just hydrogen and helium. We don't really need to talk too much about lithium because the amount was so small. Mm-hmm. And after these very first stars formed and exploded, the heavier elements like carbon, oxygen, magnesium, iron, all of that stuff was suddenly present in the gas clouds, in tiny amounts only, very tiny amounts. But that actually helped, especially the carbon and the oxygen, to make the gas cool. These atoms are more complicated than hydrogen. That's just a proton. And so it has cooling properties, can send out photons outside of the gas cloud. So the gas can cool. And when you have gas that gets colder and colder, you can make smaller and smaller stars. So you can fragment it and clump it and turn it into stars like the sun. And the cool thing about that is that when you have small stars like the sun, they have a really long lifetime. Mm-hmm. So those first low mass stars that formed back then are still observable today. That is actually what I do. I try to find these early survivors because they tell us what the gas looked like back then. They have preserved that composition of these early gas clouds, the chemical compositions, until today. So I don't need to look very far into the universe to study all the beginnings. I can just chemically analyze the oldest stars, and it's like unpacking everything that happened back then. It's very exciting.
So to just reiterate, so in the very early days, in the first few million years, there was giant stars that's mostly hydrogen and helium, and then they exploded in these supernova explosions, and then they made these clumps.
Yeah, so the first stars...
non-pristine clumps.
Yeah, pretty much.
Fun.
So it took a few 100 million years for the first stars to emerge.
Yes.
And then they exploded after a few million years. Kaboom. And then it's like, I always consider the universe like a nice soup. Mm-hmm. And then these first supernova explosions kind of provided the salt, just a little sprinkle of heavier elements. And that made it really tasty. Mm-hmm. It just changed it completely, right? And that changed the physics of the gas. So that meant that these gas clouds that were, surrounding the former first stars, they could now cool down and clump and form the next generation of stars that now included also little stars. And as I just mentioned, the small stars have these really long lifetimes. The sun has a lifetime of 10 billion years. Any star that is even less massive will have an even longer lifetime. Mm-hmm. So that gives us a chance to still observe some of the stars that formed back then. So we are testing the conditions, the chemical and physical conditions of the early universe even before the galaxy formed.
So what's the timeline that we're talking about? What is the age of the universe, and what is the earliest time we got those salty, delicious clump soups with heavier elements?
Well, the universe is 13.8 billion years old.
Allegedly, yeah. Is it
yes.
so? Okay, 13.8.
Well, when I was in high school, the universe was 20 billion years old.
Oh, yeah? So the estimate...
Things have changed.
Do you think that estimate will evolve in interesting ways or no? Is it
I think
pretty
we
stable
have
at this point?
mostly converged, yes, because the techniques are very different now, much more precise. The whole business of precision cosmology by mapping out the cosmic microwave background, that's a marvelous feat. Maybe, the digits will still move around a little bit, but that's all right.
Plus the gravitational waves and all that.
Yeah.
So all the different sources of data.
Yeah.
Kind of mapping out this detailed picture of the early universe. Yeah.
Totally. And so we think the earliest little stars formed, I don't know, maybe 500 million years after the Big Bang, right? Again, a few 100 million years for the first stars to emerge, and then, took some time. So give or take 500 million years. And that was the time when sort of the very first proto-galaxies formed, early stellar structures, stellar systems, from which the Milky Way eventually formed, right? So the Milky Way was probably a slightly bigger one. And we know today that galaxies grow hierarchically, which means they eat their smaller neighbors. So if you're the bigger one and have a few friends around, you're just gonna eat them, absorb them, and then you grow bigger. And so all these little early stars, kind of came into the Milky Way through that kind of process. And that's why we find them in the outer parts of the galaxy today, because they're just they've been just left there since.